As we are discussing about RTOS, that is real-time operating system, I have discussed few examples also. As I said earlier, this particular system, operating system, is being used or surrounded by. I mean, we are surrounded by it. In fact, I gave in examples also, wherein from our regular life, mobiles, cars. Nowadays, in you might have heard bikes. Bikes also you have sensors for fuel injection. They are time restricted fuel injection or interval restricted digitized fuel injection or igniters, and there are many. When it comes to applications, let's look into applications of real time system. Some examples: control of nuclear reactor to prevent chain reaction. As all of us a little bit aware that when it comes to nuclear power and its chain reaction, it is difficult to control when it starts. So to do that in regular interval or in a specific time without leaving the deadlines and hard requirements, there we use RTOS systems. And control of ship to avoid collision with meteors. Example, we can think of a ship. See, usually it happens when it is crossing. A ship is, we can think of very huge object. What looks above the sea is exactly almost double it, which is below the sea. So the sensors with ship will detect any um, meteors or any kind of big object which it should not collide. The biggest example what we can think of, Titanic, which did not have the technology at that time. Nowadays, smallest possible systems also have these systems. I mean, these RTO system. Control of manufacturing equipment such as lathes, scanners, etc. We use RTOS. Detecting patients' conditions in ICUs in hospital. See, in Western, almost in India also, there are equipments attached to the patient, various medical equipments. They'll detect any variation in terms of heartbeats, in terms of blood pressure, or in terms of whatever, the malfunctioning of the patient's body, and they'll immediately detect and then tell us, tell the doctors, I mean, intimate, or some kind of information is passed. In such cases we use these RTOSs. Collecting data on cosmic rays in physics researches where human intervention is not possible. In such things, RTOS helps a lot. About these, there are few more examples where these RT, that is real time systems, are used. Air traffic controllers, where exactly we use these in air traffic controlling. See, air traffic controlling, we do not have any person at the air, so everything flying of the air happens depending upon the longitude and latitudes and setting and pilot's discretion, because it is very, I mean, complex system, and it has to be with lots of sensors, radars. Here, instead of telling sensors, we need to have radars and all other things which manages which flight is landing and which flight is taking off. There should not be a collision at all, because schedule should be monitored and maintained in such a way that two landing back to back, two takeoffs back to back should have a proper interval. If takeoff somehow we can manage, but when it comes to landing, what if two or three different locations with different longitude and latitude planes have come to a particular uh, airport, and all this is done by real time systems. And then system that provide immediate updating. For example, uh, weather forecasting, where we think of soft real systems. Defense application system like radar. I gave an example. What if someone fires a missile to our territory? Before it enters our territory, it has to be destroyed in the air itself. How it is possible? We need to have a radar which can interrupt it, possibly guess the speed, size, length, and possibly what it may contain as a weapon, whether it is nuclear or any other payloads. So, and in response, it has to fire it missiles so that it can be destroyed in the air. This should be in time. That is real time. Things should happen. There should not be a person who come and hits the button. There is nothing. There should not be nothing. There shouldn't be like this. So defense systems, network, multimedia systems, where online games, where controls are being managed by multiple people across the network, and it should be of the real time. Now I am using one particular object in the game, I fire, and it should not be that the other person is hit after 2 or 3 minutes. It's not something that it should be of real time. So all these are real time systems, command control systems, internet telephony, anti-lake brake system, heart pacemakers. All these are good examples of real time operating systems. Some examples which are widely used RTOS are Linux, OSC, QNX, RTL Linux, that is real time Linux, VxWorks, and Windows CE. The maximum used are in the market, maximum used are um, VxWorks and Windows CE. These are in corporate maximum use. So this is about RTOS, wherein it is all applications where stringent requirements and time restrictions are present. In such cases we use RTOS, that is real time operating systems, wherein the previous operating systems, like whether it is a batch system, there was no time restrictions at all. And then comes multi-programming, where multiple programs or multiple jobs are run at a time. That just the illusion of running multiple jobs at a time, but the switching between the jobs was so fast that it creates an illusion such that. And then comes time sharing system, where it is a logical extension to multi-programming, where every job is given equal importance and every job gets some chance to get executed. And in both the cases, CPU was maximum in use. So let's look into advantages and disadvantages. Before that, these are the places where your RTOS is used in home appliances like digital appliances, DVDs, everywhere. You can just see on the slide. Solar powers also, home video games, fax machines, telephone, even your set-top box. In your set-top box, if it is not transferring frames properly, then you will not have a proper moving image on the screen. Then in mobile devices, our mobile device is full of sensors. In office factories, personal computers, industrial robots, it is used. Automobiles, I gave an example. Nowadays, cars are so intelligent that you might have heard driverless cars also, where it manages everything because of embedded sensors and responders. And all result in these transportation systems. Here we have plenty of applications with respect to RTOS. And even traffic management. In some countries, traffic is managed through RTOS, where heavy flow of vehicles is there. If low flow of vehicles is there, how that has to be managed. And nowadays, smart TVs have come, printers. I told you about the inkjet. Nowadays cameras are also becoming smart. They detect the face, not only face, they detect our gestures also. And ultrasound machines, micro oven. How micro oven, after a certain time it gets off, after certain times it slows down or something, whatever the adjustments we have, those all can be done in RTOS. If you look into advantage, memory management is of less importance and it is not at all demanding, because hardly we need to manage any memory. You get the input, process it, action is initiated. So no need of much memory management. File management speeds up the access of life. Here we are not managing much files, but whatever we have, it speeds up. Resource management is of less importance because everything is on real time basis. There is no concept of I need to manage this particular resource and all other things. Hard real time system may not have secondary storage. I told you, we do not have secondary storage with respect to hard real time because get the data, process it, and action is initiated. What are the disadvantages? There is a rigid time limit. That is the only disadvantage what we can think, and the biggest disadvantage. Very costly to implement because we need a lot of embedded systems, embedded system programmers, sensors, and after sensing, the program to initiate the actions and all. This is the big disadvantage. If fails, it leads to huge problems, very huge problems. Sometimes aircrafts have been destroyed, sometimes the entire space mission disrupted. So many examples we can quote on when it comes to if it fails. If it fails. So these are the advantages and disadvantages, and this is how the real time operating system works.